Here is a generic right triangle and the Pythagorean theorem. I'm going to draw another right triangle. This one a little more specific. It's going to have two congruent sides. So it will be an isosceles right triangle. Now the base angle theorem says that the two angles that aren't the 90-degree angle have to be equal to each other, so they need to be 45 degrees each. Now, since it's isosceles, I don't really need a B. The two sides are A. Now, if you look at this, the hypotenuse is C. When you use the Pythagorean theorem, you wind up with A squared plus A squared is equal to C squared. You can combine the A squares so that 2A squared is equal to C squared. And then if you take the square root of both sides, you wind up with a way to express C in terms of A. C is equal to the square root of 2 times A. So we actually don't need to use the C at all. The hypotenuse will be A times the square root of 2. That means anytime anyone tells you, here's an isosceles right triangle with a leg of this big, you know that the hypotenuse has to be that same number times the square root of 2. Now let's look at the same kind of triangle again, but think about what it would be like if instead of being given A, the length of the leg, you're given the length of the hypotenuse. So this time, we're given C. Well, it's still going to be A squared plus A squared is equal to C squared. And that's still going to be 2A squared is equal to C squared. And if you take the square root of both sides, square root of 2 times A is equal to C. But what we want to do now is solve for A. So we divide both sides by the square root of 2, then rationalize the denominator by multiplying top and bottom by the square root of 2, and we wind up with square root of 2 times C over 2. So in other words, if I tell you here is an isosceles right triangle, and the hypotenuse is C, it means that the legs are going to be the square root of 2 times the hypotenuse over 2. Square root of 2 times the length of the hypotenuse over 2. These are the only two ways you could be given information about an isosceles right triangle.